It is indeed possible to use a boost transformer and a power converter to obtain 460 volts, three-phase power starting from a 120/240 volts single-phase source. Here's a breakdown of the process. Firstly, you'll need a boost transformer. Install a 120/240 volts to 460 volts boost transformer. This transformer will elevate the voltage to 460 volts, but it will remain single phase. Secondly, a power converter is required. Connect a three-phase power converter to the output of the boost transformer. This power converter will then transform the single-phase power from the transformer into three-phase power. Now let's consider some electrical aspects. The power converter must be adequately rated for the power demands. Ensure the power converter is rated for 2.8 kilowatts, which is the specified power requirement of the bandsaw. Voltage is crucial. The boost transformer must provide sufficient voltage gain to achieve the desired 460 volts. Furthermore, a power converter must be designed for phase conversion. Specifically, it should be a 1 to 3 phase converter, capable of converting single-phase power into three-phase power. There are other factors to consider. Efficiency is a key factor. Keep in mind that both the transformer and power converter will introduce some efficiency losses. As a result, it might be necessary to acquire a higher rated converter to compensate for these losses. Cost is also important. Boost transformers and power converters can be a substantial investment, so the cost of this approach needs to be carefully considered. Safety cannot be overstated. Proper electrical wiring and grounding are paramount to ensuring safety. It is highly recommended to consult with a qualified electrician for both the installation and ongoing maintenance. If the cost or efficiency of utilizing a transformer and converter isn't optimal, there are alternative solutions worth exploring. One such alternative is using a phase converter. Employ a 1 to 3 phase converter to directly convert the single-phase power into three-phase power. This method might prove to be more economical than the combined transformer and converter setup. Another potential solution involves upgrading the power service. Contact the local utility to inquire about upgrading the electrical service to three-phase 460 volts. While this option offers the most reliable and efficient solution, it could also be the most expensive to implement. Let's go into some more detail regarding transformers. A transformer is a passive electrical device that transfers electrical energy from one electrical circuit to another or multiple circuits. A varying current in any one circuit of the transformer produces a varying magnetic flux in the transformer's core, which induces a varying electromotive force across any other circuits in the core. Electrical energy can be transferred between multiple circuits coupled through a common core. Transformers are used to increase or decrease the alternating voltages in electric power applications. A varying current in the primary winding creates a varying magnetic flux in the transformer core, which induces a varying voltage in the secondary winding. This effect is called mutual induction. If a load is connected to the secondary winding, an electric current will flow in the secondary winding and transfer energy from the primary circuit to the secondary circuit. Transformers can change alternating current voltages with only a small loss of power. Transformers help make sure electrical equipment is powered correctly and safely. Transformers come in different sizes and designs to fit different needs. They are usually used in power grids, electronics, and appliances. When selecting a boost transformer, it's important to determine the required voltage and current ratings. The transformer should be sized to handle the load of the bandsaw plus any additional loads that may be connected to the circuit. Consider the transformer's efficiency, as this will affect the overall energy consumption of the system. A higher efficiency transformer will result in lower operating costs. Look for transformers that meet relevant safety standards and certifications. A power converter, also known as an electronic converter, is an electrical circuit that changes one form of electrical energy to another. It is a type of electric power supply. Power converters can be classified into many types depending on the ratio of input voltage and output voltage and the nature of the output signal. Alternating current to direct current rectifiers convert alternating current to direct current. Direct current to direct current converters convert direct current voltage levels. Direct current to alternating current inverters convert direct current to alternating current. Alternating current to alternating current converters convert alternating current frequency or voltage levels. In this scenario, the power converter is used to convert single-phase alternating current to three-phase alternating current. When selecting a power converter, it is important to consider the input and output voltage and current requirements. The converter should be sized to handle the load of the bandsaw. Consider the converter's efficiency, as this will affect the overall energy consumption of the system. A higher efficiency converter will result in lower operating costs. Look for converters that meet relevant safety standards and certifications. When connecting the boost transformer and power converter, follow the manufacturer's instructions carefully. Ensure that all connections are secure and that the wiring is properly insulated. Use appropriate grounding techniques to prevent electrical shock hazards. Before energizing the system, double-check all connections and verify that the voltage and current ratings are correct. Use a multimeter to measure the voltage and current at various points in the circuit to ensure that the system is operating within its specified parameters. Regularly inspect the boost transformer and power converter for signs of wear and tear. Check for loose connections, damaged wiring, and overheating components. Perform routine maintenance tasks such as cleaning and tightening connections to ensure optimal performance and longevity. Keep the equipment clean and free from dust and debris. If any problems are detected, such as unusual noises or erratic behavior, disconnect the system immediately and consult with a qualified electrician for diagnosis and repair. When working with electrical equipment, always follow safe work practices. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. To energize the circuit before making any connections or performing any maintenance. Use lockout-tagout procedures to prevent accidental energization of the circuit. Be aware of the potential hazards of working with electricity and take precautions to avoid electrical shock and burns. Never work on electrical equipment when you are tired or distracted. If you are not comfortable working with electricity, seek assistance from a qualified electrician. The National Electrical Code, or NEC, provides guidelines for electrical installations. Always follow the NEC and local electrical codes when installing and maintaining electrical equipment. The NEC contains information on wiring methods, overcurrent protection, grounding, and other safety requirements. Familiarize yourself with the NEC requirements that apply to your installation. The NEC is updated every 3 years, so it is important to stay current with the latest edition. Electrical safety is paramount. Always prioritize safety when working with electricity. Educate yourself about electrical hazards and take precautions to avoid accidents. Consult with a qualified electrician if you have any questions or concerns. By following these guidelines, you can safely and effectively convert single-phase power to three-phase power for your bandsaw. Remember to prioritize safety and consult with qualified professionals for assistance as needed. Keep in mind that power converters and boost transformers generate heat and need to be installed in a well-ventilated area, away from flammable materials. Make sure the devices are properly fused. Use correctly sized conductors per NEC table 310.15b16 and grounded to prevent electrical shock. Be sure to label all electrical panels and equipment clearly to identify the voltage and phase configurations. It's important to select a power converter and boost transformer that are compatible with each other. Check the manufacturer's specifications to ensure that the output voltage and current of the boost transformer match the input voltage and current requirements of the power converter. Using mismatched equipment can damage the devices or create a safety hazard. Before making any electrical connections, make sure to turn off the power at the main breaker. This will prevent accidental electrical shock. Use a voltage tester to verify that the power is off before proceeding with any work. When working with wires, use appropriately sized wire connectors to ensure a secure and reliable connection. Loose or poorly connected wires can cause overheating and electrical fires. After making all the connections, double-check your work to make sure that everything is wired correctly. Consult the wiring diagrams provided with the equipment to verify the connections. Before turning the power back on, inspect the installation to make sure that there are no exposed wires or other potential hazards. Use a non-contact voltage tester to check for any stray voltage. When turning the power back on, do so slowly and carefully. Watch for any signs of problems, such as sparks, smoke, or unusual noises. If you notice any issues, turn the power off immediately and investigate the cause. Regularly inspect the electrical installation to identify and address any potential problems before they become serious. Look for signs of wear and tear, such as cracked insulation, loose connections, or corrosion. Schedule regular maintenance checks with a qualified electrician to ensure that the electrical system is operating safely and efficiently. A qualified electrician can perform a thorough inspection of the electrical system and identify any potential problems. They can also perform necessary repairs and upgrades to ensure that the electrical system meets current safety standards. If you are planning to make any changes or additions to the electrical system, consult with a qualified electrician to ensure that the work is done safely and in accordance with local electrical codes. Adding new circuits or equipment can overload the electrical system and create a fire hazard. It is essential to consider that electrical codes and regulations vary depending on the location. Always comply with the local electrical codes and regulations when installing and maintaining electrical equipment. Local electrical codes may have specific requirements for wiring methods, grounding, and overcurrent protection. The NEC is a widely adopted standard, but local codes may have additional requirements. Consult with the local building department or a qualified electrician to determine the applicable electrical codes and regulations. If you are unsure about any aspect of the electrical installation, seek professional assistance from a qualified electrician. Working with electricity can be dangerous, and it is important to take all necessary precautions to ensure safety. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in compliance with applicable codes and regulations.